Okay, hello everyone. Welcome to another one of our design reviews heading for Wolfram Language version 13.1. This is another iteration of machine learning design review. So we last time talked about feature impact plot, and I think we're down to train image content detector. Is that correct?
Yeah, there's not much to see there in the documentation because nothing is explicitly changed. It's just that it uses a better network underneath a more modern network, so it's smaller and it's
Is it faster?
almost same, a little one to evaluate. It's a little slower to no, it's almost at the same time to train, I would say.
What have we used this internally yet to train anything particularly interesting?
Well, I have a bunch of detectors trained for the benchmark, of course. But we could, in principle, do something more. I want to retrain as soon as we are done with the image identify retraining. I want to use it to retrain image cases.
Hey, can I train it on my handwriting?
To find your handwriting in an image?
To identify the letters.
Yeah.
Could I train it on something? Because like I've got things that I wrote out, 40 years ago where I've got the written version, I've got a typed version, which is OCRable. I mean, if we could segment the letters, I don't know. I'm just trying to look.
I think it will be a bit uphill. You would probably get better results. I think Mikael had a demo project for handwriting recognition. And using a specialized network probably saves up tons of training time.
Okay. All right. Okay. But I mean, it would be good to use this and put some results in the neural net repository if we can.
Yeah. That was the idea. We just got stuck on this image identify retraining that we wanted to tackle first, and we're using it to update a bunch of things in our training pipeline, internal training pipeline, that will reflect also outside.
Okay. Find clusters.
So that's the I put tentative a new proposal.
This is very. I mean, by the way, is this okay that I skip these ones? I mean, this is.
Well, if you are curious, you can go to the feature value dependency plot. I put an example that you suggested last time about the. I mean, I still have to refine that a bit, but it shows how with the linear. No, sorry, not this one. The feature value impact plot. I'm getting confused myself. You can click on the related features.
Come on, we can do better here.
No, that's a bug. It's using transform features. I'm fixing that. So this is why there are not so many examples here.
Okay.
The feature value impact plot is the number 3 that you had there. You were asking if we can see the impact for a linear detector and a non-linear. And so if you go to the first example, you'll see that, so this is a simple linear model, and you see immediately that the linear data, linear model, and you see that the impact is distributed in a linear way around the average, and it's exactly the difference between the predictor mean and the predictor output.
Okay.
And if you look at the second one, you have a non-linear data set. And if you try to predict it with a linear model, you see that the two features are, of course, uncorrelated. I mean, each one gives its own impact. But if you use a non-linear model like gradient boosted tree, now suddenly each example will split according to the other feature because there is a non-linear effect. And so
kind of nice.
Like each example has an impact of feature 1, which is also conditioned on feature 2 in this case.
Boy, one of the things that could be an update to Etienne's book already.
Yeah, I mean, this. I'm building some of these. It will grow a lot. The example section. It can show a lot of things for all these models.
That's interesting. That's good. Is this our multi-panel plot?
Yes.
That has this weird gutter thing between the two plot regions?
I'm using the default one. I haven't changed anything, but we already found some issues that I reported all to. Like I'm working with Brett to enumerate all of these, so he's giving another look at this. I can report also this gutter thing.
Well, I mean, I think I thought we were going to slightly lighter gray frames when we had all these frames. I don't know. It just doesn't. It looks a little weird. It's not terrible.
So there's no aesthetic update for 13.1. There will be for 13.2. We're gonna. So it's the same as 13.0.
Okay. All right. Fine.
But of course, this is using the default one, so it will inherit whatever updates.
Fine.
There.
Okay. Find clusters.
Okay, so the main difference here is that people were asking for. So this is the slight breaking change that we discussed before. Like right now, if you say find clusters data comma n, it's basically up to n. And
yes.
People are very confused by this. So now I made it so that n is actually n, and up to n is supported and is the old behavior.
Why don't you put that in the box up here, an up to n thing? I think you should.
Okay, yeah, it's explained. It's explained down there, but I can promote it to the top.
Well, oh, maybe it's okay down here. So long as there's an example fairly quickly with it.
Yeah, I'm waiting for the PR to be approved, but yeah, this is ready. I will put examples here as soon as this is merged into master.
Okay.
One slight design thing that we are trying to solve here, maybe would be nice to discuss it here if there are preferences. The team is a bit split on this, so we don't have a consensus. Is what's the best result if you have only 3 points and you ask for 10 clusters? Like, do we pad with empty clusters, or we just fail with the message that you don't have enough points? I'm trying to think which one is the neatest in terms of like I mean, this thing of n. The main use case is that you don't want to be bothered, of checking that each like you're clusterizing a bunch of things, and then you need to go in and check again that each one has exactly n clusters. So like this will fix that. So I'm trying to think which is the expectation here.
Wait a minute. If you have too few data points for the number of clusters you've requested.
Exactly. You have like 3 points and you ask 10 clusters.
Well, I think you should get a message. And then it should just return every point in its own cluster.
Okay, so we do break the fact that the length of the cluster list is exactly n in this case.
I think we give a message and we break. That's what I think.
Okay. And by break mean not returning.
No. I mean, I think then we return the thing with whatever clusters we can get. What do you think, Roger? Do you have a comment on that?
I mean, how important is it to get exactly 10? Because you can have up to 10, in which case you need to check how many you get.
Yeah.
If it's super important, sure, you can have a bunch of empty lists, but it seems
no. We don't want to do that. Okay. Okay, I think it's fine. I mean, if you give a message and then you give the wrong number, it's just fine.
Okay.
Okay.
Which is, I think, is the current implementation right now.
Okay. So, clearly we need to be looking at these other neural net frameworks. And have you been actively looking at those or not?
Yes, of course.
Okay.
We have a design, like our monthly check-in where we can discuss strategy about that. But yes.
Okay, fine.
But that's I mean, on NX, I think it's something that we have good support for, and it's a good exercise for us to finish it. And I think until it exists and it's used, we want to keep it. It makes no sense to drop it.
Sure.
Oh no, I mean. No. We need to always support Onyx, I think, for foreseeable future.
Exactly, and so Matteo is doing good job in terms of like being able to import everything that exists in Onyx, and on the converse, like adding export for our more exotic operators. Like we have a very customized attention layer, like some folding operators. So all of these can now be exported on NX.
Okay. All right. So which of these things should we be looking at here?
I mean, these are like all a bunch of like, we support a lot more things for these layers. I don't think that any of the one below require like specific attention. The more visually impactful ones are the update to the net encoder, net decoder, that the class decoder and the image encoder, that basically are like compilation of a lot of features that were like missing, and then we added. So the class decoder is you can use the fourth one in the list.
Mm-hmm.
We needed a much more refined sampling strategy for text generation, which now we have. I think if you click on class, you'll see that the 1, 2, 3, 4.
Do we have a separate documentation for that?
Yes,
yes,
for each one of them. So if you scroll down a bit,
wait a minute. What is this? How does it indicate? Why doesn't this source page indicate what type of a thing it is?
It does when it's built.
Okay, so I'm going to make a suggestion. This is for Avery, to feed back to the DocuTools people the fact that these source pages should have some indication of what type they are, because it's pretty confusing. I'm not seeing what this is.
Yep, I can do that.
So you see that we added, if you scroll up to the nodes.
Which I'm sorry,
yeah, we added these temperature probability cutoff and top probabilities, which these are called typically top K and top P sampling. So you, if you're sampling from a distribution, you only take the first like K classes by probability, or the top P, the nucleus samplings, you accumulate the probability up to a certain cutoff. And this gives rise to a much more natural like language generation model, for example.
okay.
So the performance of our language generator models is improved dramatically due to this. And we can actually now reproduce the results from GPT-2 and the models that we have in the repo. They are much better matched to what's in the literature.
That's good.
And another nice one, which is I think will allows us to get away with a lot of custom encoders, is the image encoder has been updated to support a lot more specification for images, like custom resampling, custom padding. Basically, this is very useful for all the object detectors, and it's doing something similar to what conform images can do, or image collage, like stretch the image, fit the image to a specific shape, not just simple resizing. And this is interesting for object detection because you don't alter the aspect ratio of the image, and so you can detect more easily all the objects.
Wait a minute. So
I have some visuals. If you click on the net encoder and then image, you can immediately see that. See, like the final 4 options are new. And according to the method option, you have different.
Okay, but so, I mean, this is, how are we rippling through our various existing networks and so on to make use of all these fancy new options?
Well, there was a bit of debate about this. The research system now supports proper versioning. So what the path we chose is to leave. if you call the network from an older Mathematica, or whatever Wolfram language version you're using, it will use the most up-to-date model compatible with that. So like we don't want to break compatibility. It will still work on version 10 if it was released with 10. But if you download it from a new version, you will get like richer layers, richer encoders, richer decoders, or a simplified structure if it's possible. So we are doing this for all the models where it makes sense, basically.
Okay. Good. All right. Well, let's see. Anything else that we need to look at in this meeting?
Documentation-wise, no. I mean, the rest was pretty fast. I didn't know if you wanted to go through the impact plots again, but if you're satisfied with those names, I think if you're satisfied with those names,
I'm satisfied with the names. I like them.
Okay. We have clear idea for the design. We have ways to specify features and classes, and so I mean, it seems pretty solid now at this point. The only thing
were there visual design issues as well?
I mean, there are some things that came out while I was reviewing with Brett, but I reported. I mean, they're all like little bugs in visualization, that things we don't like placement of labels and stuff like that. But they're not specific to these functions. We're like stress testing some of them a bit more.
Okay. Sounds good. All right. Anything else to look at here?
I guess not. If you don't, there's nothing very documentation oriented. There's a lot of under the hood updates on loss functions, and
what's happened to the progress monitoring stuff?
Yeah,
I haven't heard much in this version about progress monitoring. A lot of functions. Go ahead.
It was an under the hood project, so like it's been I don't know. I updated manually ping time, net train, and the classify predict are using the new system. So now if you go to the classify page and you train, you see it's using the new the new progress grid.
Okay.
And I think Avery has a big notebook where he's tracking all the updates, but it has been propagated to quite a few functions now at this point.
Good. Well, I mean, but what's the roadmap for propagating it to yet more?
Well, the difficult one I'm helping, and I think Avery is pestering every team with. Are you here, Avery?
Yeah, I'm here.
Okay. I mean, we do keep an up-to-date list, and you are like once in a while you are pinging the things that are not transitioned yet. Yeah,
but
more or less.
I was too fast.
Just use time goal and a big number.
Yeah.
Time goal 1,000 or something like that.
That looks very similar to the way it looked before, doesn't it?
Well, the design of the new one wasn't too far apart from the old one. It doesn't have buttons anymore, and I mean this one I don't know why probably Markov doesn't have the.
I see display visual, the big
big thing, yeah, because it's just one model here. But the first one is showing it. So the thing is, it is aligned. I mean, if you look at them side by side, now they're all aligned. Basically, they're not using anything custom anymore. That was the main point. And they use the common infrastructure. So if we ever decide to update it, they will all be updated at the same time.
Okay. Well, this is good.
Then we have a discussion. We had the discussion about monitor and other updates, but I think that's a separate thing. Is like how we bring it to top level. But it's kind of on a separate track than updating the internal progress monitoring.
Yes, but we want that. I mean, we talked about that in another meeting and being able to monitor map and things like this.
Exactly. We are tracking that during the LCC meetings.
Okay. Listen, let's declare victory. We are early here.
Okay.
It's great because I've got other things that I need to take care of before.
Fine by me.
So good work. All right, Roger, we're not missing anything, are we?
No.
Excellent. Thank you for being early. Okay. See you guys.